With 1997, AB 77, the calculator question, it says the graph of the function y equals x cubed plus 6x squared plus 7x minus 2 cosine x changes concavity at x equals what? Well, y changes concavity when y prime prime, or the second derivative of y, changes sign. Maybe from positive to negative, or maybe from negative to positive, but as long as it changes sign, then there will be a change in concavity. Now, being that this is a calculator question, I could first find the derivative and plug that in. I could even first find the second derivative and plug that in and look for a change. I'm going to start right away with the actual function plugged into the calculator. And when I do that, I end up with, it's actually in y2 right now, but it doesn't really matter. The function x cubed plus 6x squared plus 7x minus 2 cosine x. Now, what I want to do, though, is I can do this using only the first derivative. And the way I'm going to get the first derivative is to go to Math, and then up to NDeriv. Now I have the new operating system, so yours might be a little bit different. So it would be the variable I'm differentiating with respect to is x, and I'm going to use yvars function y2 in this case. Yours might be y1. And finally, I'm going to set x equal to x, which means that I want to have this draw a graph for all values of x. Now over to the left here, I've written what that would look like if I were not using the new operating system. So it would be y3 is equal to nderiv y2, which I get from yvars function y2, x comma x. The first x is the variable with which I'm differentiating, the variable that I am differentiating with respect to. And the second x would be the value that I want to find the derivative at. And when I put in x, it finds it for all values. Right? So this gives me the first derivative. And remember, I can tell when the first derivative changes from increasing to decreasing, or changes from decreasing to increasing, that I will have a change in concavity in the original function, or a change in the sign of the second derivative. So I go to graph that. I need to turn off the first function, though. So I make sure I go up there, turn off the first function, and then graph. So again, what I'm working with here is the first derivative. And the first derivative, remember that the slope of the first derivative is the second derivative. And now I've pasted a copy of that graph onto my workspace, and what I'm looking for, you can see that the slopes change from decreasing, or that the slope changes from being negative to being positive at the vertex. So that point down there, that x value, is where the function changes concavity. So now if I go back to the calculator, what I'm looking for is a minimum. And I get that by going second, calc 3 for minimum, and I can go back to the left, then a little to the right, and a guess, and I end up with an x value of negative 1.89. And so that is the answer to this. Remember, the question asked, where does the original function change concavity? It will change concavity when the first derivative changes from decreasing to increasing. That is at x equals negative 1.89.